Hey everyone, so we are moving into solving applications of quadratics. So we know how to solve them, we know how to graph them, all the things. So now we're going to do some word problems. All right, so start with this. This is a review of an Algebra 1 word problem. The length of a rectangle is 3 more than twice the width. If the perimeter is 20, find the dimensions. So we've got our rectangle. The length is 3 more than twice the width, right? So when you have a rectangle, opposite sides are the same. With perimeter, we add everything up, goes around the outside. So we have 1, 2, 3, 4, 5, 6W plus 6. 6W is 14. So W is, if we divide by 6, that's 7/3. All right, find the dimensions. So 7/3 is the width, so 7/3 by, we always write dimensions like that. And we gotta plug in for the length. So that's 14/3 plus, change the 3 to 9/3, and we get 23/3. That's our answer. Okay. So today we're going to focus on ones where I give you the equation. Those are the easy ones. It's writing the equation that can be challenging. If X represents the number of items sold and P of X represents profit, find the maximum profit using the following equation. So we want the maximum profit, right? So think about this graph. What does that graph look like? It's a parabola that's upside down. So what would be a maximum point? There. So typically when you're solving a quadratic, it's either going to ask you for the max or it's going to ask you for the zeros. Like that's max, min, zeros. Those are usually, you just have to identify which one it's asking for. So how do you find the vertex of a parabola? Negative b over 2a. So negative 16 over 2 times negative 2. It's negative 16 over negative 4, which is 4. So 4 is the X value. X represents the number of items sold. And it wants the profit. So we need to then plug in to find the profit. So P of 4, negative 2 times 16 plus 16 times 4 minus 22. Negative 32 plus 64 minus 22. 32 minus 22, I got 10. And there's no like real units here, so the profit is 10 something, who knows, $1 million if it's a real company. All right. Assume the number of liters of water remaining in the bathtub varies quadratically with the number of minutes which have elapsed since you pulled the plug. This is found by this function. All right, so that's our function. Sketch a graph. So pause the video. You could try this on your own. So let's see. So we're going to sketch a graph of the function, label the critical points. So we got, I'm going to factor out 2.4. So I have 2.4 t squared minus, what is that, 10? My brain isn't working this early in the morning. 10t plus 60 divided by 2.4, 25. Okay, cool. So this is 2.4, and then if I factor that, I get t minus 5 squared. So at 5, this graph looks like this, and it hits 60 here, right? So our critical points here, our minimum is also on the x-axis or the t-axis, and the y-intercept is 60. How much water was in the tub when you pulled the plug? What do you think? Well, that would be t equals 0, right? So if you plug in 0, right, v of 0 is just 60. That's we starting out with 60, does it give us a unit? 60 liters of water, and then it goes down. Right? So 60. When will the tub be empty? Well, when is the amount of water, assume the number of liters remaining in the bathtub varies. I'm just trying to figure out what we've got minutes and liters. So when is the liters equal to 0? 5. When, right? When is a time. So they're asking for a time. In the real world, the number of liters would never be negative. What is the lowest number of liters the model predicts? Is this number reasonable? So the lowest number would be 0, right? But I guess what would happen is on the right side of it, it would start filling again. Yeah. I don't know what else that would mean. So is this number reasonable? Definitely. Yep. We're not going negative, so that makes sense. All right. Again, pause the video. These are not that hard. It's just that the equations tend to be really weird. So break out the graphing calculator and use it. On a trip to St. Louis, you visit the Gateway Arch. Since you have plenty of time on your hands, you decide to estimate its altitude, so height. You set up a Cartesian coordinate system with one end of the arch at the origin and the other on the x-axis. So we have those are the two bottoms of the arch. The x-axis represents the horizontal distance. The y represents the vertical distance. The horizontal and vertical distances can be found using this model. So we have these crazy decimals. So how far apart are the two ends? So what are we doing there? We're factoring, right? We're setting the whole function equal to 0 and solving. So we've got negative 0.0283 x squared plus 4.578x equals 0. Now, let's see if you can factor out the decimal. I'm not sure if you can. Yeah, that decimal doesn't go in easy, so we're going to have to round. So I'm just going to pull out the x. So if I factor out an x, I get negative 0.0283x plus 4.578 equals 0. So we have the x equals 0, which we knew, right? X equals 0. And then for this one, we get, I'm going to subtract 4.578, sorry, over negative 0.0283. Let's see what we get. Negative 4.578 divided by negative 0.0283. I got 161.767. So that's how many, what is this in? Horizontal meters. So 161.767 meters. How tall is the arch? So that would just be your 1B is starting. That would just be your negative b over 2a, right? So negative b, so negative 4.578 over 2a. Writing this decimal is really annoying, but oh well. Let's see what we get. I got 80.883, and then that's the x value. So then we need the y value, so now we're going to plug that into the equation. And I got 185.142 meters. An airplane with a wingspan of 40 meters tries to fly through the arch at an altitude of 170 meters. Could the plane possibly make it? So at 70 meters, so if this whole is 170, if this is 185, 170 is like here. So we need to figure out if this is the plane, right? I can't draw planes. So there's my plane. If this is a plane, at 170, will these reach? So take a guess. What do you think we should do? We are going to set our equation. We need to know the x's when the y is 170, right? This is a y value of 170. So we're going to set our equation equal to 170 and solve. Definitely use quadratic formula because this is terrible. Right? So negative 0.0283 x squared plus 4.578x equals 170. So then subtract the 170. I'm just going to do this because I'm running out of space. All right, so quadratic formula. Pause and do it if you haven't yet. All right, so we get negative 4.578 plus or minus the square root all over 2, negative 0.0283. So this is b squared minus 4ac. 4.578 squared minus 4 times negative 0.0283, negative 4ac times negative 170. I got 1.714. So we then have negative 4.578 plus the square root divided by 2 times 0.0283. Uh-oh, I did something wrong. All right, let me pause. Okay, I got x equals 57.753 and x equals 104.014. So the wingspan was 40. Will it make it? If I subtract 104 minus, say, 58, it'll make it. So it's yes, because the distance between those two x values is greater than 40. All right. So this is just kind of a general explanation. I'm not going to make you memorize this. You will have to know this when you get to physics, if you take physics. So this is a general equation based on gravity. So 1/2 gravity t squared plus initial velocity t plus initial height. So the gravity due to gravity is 32 feet per second, and it's or 9.8 meters per second. And then it's negative. See how it's negative? Because gravity pulls you down. So it's really common to be using the formula negative t squared. Whoops. Half of 32 is 16. So negative 16 t squared plus your initial velocity t plus your initial height. That's just a really common formula that we use. And you will do that in physics also. So when you're given an equation such as this, notice that 16t squared, you can kind of look at, okay, what do the numbers in this mean? So it says an arrow shot straight in the air with a speed of 112. So that's our initial velocity is 112. The distance above the ground. Notice there's no c value. That's because it started at 0. Right? So this, it's the arrow shot in the air, and it comes back down. Right? Do negative b over 2a, you can find the vertex and this point. So let's see. If we factor it, if I factor out 16t, let's see what I get. 112 divided by 16 is 7, so 7 minus t. So we get 7. Right? So 0 to 7, and then we can find the vertex, the negative b over 2a, or the halfway between 0 and 7 is 3.5. So this is 3.5, and then plug 3.5 in, and I got 196. All right, so those are the important points. All right, how high is the arrow after 2 seconds? So after 2 seconds, so again, what's our formula? It was 112t minus 16t squared. So how high? We're just going to plug 2 in, right? H of 2. 112 times 2 minus 16 times 4. 112 times 2 minus 16 times 4. 160. At what other time is the arrow at the same height that it is after 2 seconds? All All right, so now here's a good, a couple ways to do this. So one thing you could do is set the equation equal to 160. So I want to know, when is the height 160 again? And that's how I do it. A lot of kids come up with other ways to do this. I'm going to get 0 on one side, 16t squared minus 112t plus 160, divide by 16, factor. So at what other time? So we got t equals 2, which we knew, and then t equals 5. Another way I've seen students do this is using our picture that we drew, right? This was 3.5, and we found 2 was 160, right? So if you reflect the 2 over your horizontal asymptote, this is 1.5, 1.5 away. So 2 plus 3 is 5. So that's another way, is using the symmetry of a parabola. All right, keep going. After how many seconds will the arrow hit the ground? Well, we did that already, right? So pause the video and answer as many of these as you can. How many seconds will the arrow hit the ground? T equals 7. How many seconds is the arrow at its maximum height? We did that, 3.5. What is the maximum height? We got 196 when we did that. After how many seconds is the height of the arrow 96? So this is where you need to do what we did before. So 112t minus 16t squared equals 96. So set the equation equal to 96 and solve. So we get 16t squared minus 112t plus 96 equals 0. Factor out of 16. 7t plus, oh, I don't know. I know it goes in. I think it's 6. 96 divided by 16. Yeah. 6. Factor. So we get t equals 1 and t equals 6. After how many seconds is the height of the arrow 96? So there's 2 answers there. Okay. Same idea. Same type of problem, very similar. Try this one on your own. And start by sketching the graph, and like I did in the other problem, going through and starting off by just finding my zeros and my vertex made the rest of this problem super simple. All right, let's see. I'm going to factor out negative 16 t squared minus 6t minus 7. These problems are like, this is like the same problem. T minus 7, t plus 1 equals 0. So notice we get negative 1 and 7. So that's a little weird because, right, we can't go negative. So what that means is we have our C value of 112, right? 112. This thing goes up. That means it was released above the 0. So the reason, so at 0, we're at 112. So maybe we're at the top, say it's shot off the roof of a building. So the building's 112 feet high. And so that negative 1 really doesn't mean anything in terms of the problem. All right, so then we're going to do negative b over 2a. Or what's halfway between negative 1 and 7. I think it's 4. Negative 9, oops, my pen turned off. Negative 96, negative b over 2 times negative 16. Negative 96 divided by negative 32. No, it was 3. So we have 3 in the middle, and then we plug 3 in. Negative 16 times 9, 96 times 3. Plus 112. And I got 256. All right. So now I made my picture, and then a lot of my answers for later on will probably be on this page. So keep this handy. All right, after how many seconds is the object in the air before it reaches its maximum height? Well, that's just the x value of our vertex, right? Seconds. So that's our t max. So it wants the t value at the max, which we found was 3. What is that maximum height? We found 256. After how many seconds does the object hit the ground? 7 seconds, right? This is the zeros. Hit the ground. Think ground, roots. T equals 7. What is the height of the object after 5 seconds? Okay, so we have to actually do some work. We're going to plug in 5. Negative 16 times 5 squared. 96 times 5 plus 112. Let's see what I get. I got 192. So I'm a bad math teacher. I don't focus on units unless the problem specifically says include units. I just don't. So all right, that's it. Okay, so that was all our problems on where I give you the equation, and so you're going to have some practice. They're pretty self-explanatory. They're not overly hard. The hard ones are where we have to write the equation ourselves.